1925, a young PhD student makes a discovery that fundamentally changes our understanding of the stars. She conducts the necessary calculations and double-checks every figure. She includes it in her dissertation, but one of America's most influential astronomers writes to her, saying it's impossible. Under pressure, she is forced to recant her findings just to get her work published. And just a few years later, this same astronomer reaches the same conclusions, and all the glory from the scientific community goes to him. This is the story of Cecilia Payne-Gaposchkin, the woman who first discovered what stars are actually made of. Cecilia Payne was born on May 10, 1900, in the small English town of Wendover. Her father died when she was only 4. Her mother raised 3 children alone. Cecilia excelled in her studies, but for a woman in early 20th century England, entering a university meant playing by someone else's rules. At Cambridge, women could study, but they couldn't receive degrees. 4 years of hard work, not a single official document to show for it. Because that's what society had decided. She entered Newnham College in 1919, initially to study botany. But then, something happened that changed the entire course of her life. December 2nd, 1919, a lecture hall at Cambridge. Arthur Eddington, one of the greatest astronomers of his time, takes the stage. He had just returned from the island of Principe, where he confirmed Einstein's general theory of relativity during a solar eclipse. He spoke of stars, space, and how gravity bends light. Cecilia was one of only 4 women in the room. She went back to her room and transcribed the entire lecture word for word from memory. Right then, her world shifted. She decided she would become an astronomer. But there was no place for her at Cambridge. Astronomy was considered a branch of mathematics, a field closed to women. She attended lectures unofficially, sitting in halls where her presence was simply ignored. Finally, she approached Eddington himself. She told him she wanted to be an astronomer. He replied, "I see no insuperable objections." It was the warmest support she would ever receive at Cambridge. In 1923, realizing a woman's career in astronomy was impossible in England, she wrote to Harlow Shapley, the director of the Harvard College Observatory. Shapley invited her to America. Cecilia Payne crossed the Atlantic and began building something legendary: Harvard. The early 1920s, the observatory held thousands of glass plates with stellar spectra, each line a chemical fingerprint. At the time, the prevailing view was that stars were made of the same materials as Earth: iron, silicon, and other heavy metals. But Cecilia applied a new theory by Indian physicist Meghnad Saha, the ionization equation, to stellar spectra. She proved that the difference between the spectra of various stars wasn't due to a different chemical composition, but rather a difference in temperature. And then, she saw something no one had seen before: hydrogen. It was everywhere, not just more than on Earth. 1,000,000 times more. Stars aren't hot rocks. Stars are mostly hydrogen and helium, the 2 simplest elements in the universe. Cecilia checked and recalculated, again and again. The result didn't change. 1925, her dissertation, Stellar Atmospheres, became the first ever PhD in astronomy from Harvard. A discovery that should have changed everything. Before publication, the dissertation was sent for review. It went to Henry Norris Russell, the most authoritative astronomer in America, director of the Princeton Observatory, a man whose word could make or break a career. Russell read Cecilia's work. He admitted her work was brilliant, but added that it was clearly impossible for hydrogen to be 1,000,000 times more abundant than metals. He believed the issue wasn't the stars, but the theory Cecilia relied on. Saha's ionization theory wasn't yet universally accepted, giving Russell scientific grounds for his skepticism. Cecilia Payne didn't dare challenge the authority of a man who was, without exaggeration, considered the dean of American astronomers. Without his approval, her career would be over before it started. So, Cecilia did what was expected of her. She added a line to her work. The enormous abundance derived for these elements in the stellar atmosphere is almost certainly not real. But she didn't delete her data or her calculation tables. Perhaps because of that, we know for a fact, she was first. 1929. 4 years later, Henry Norris Russell publishes his own paper. He reached the same conclusion using a different method. Stars are indeed mostly hydrogen. In his paper, he wrote, "The most important previous determination of the abundance of the elements by astrophysical methods is that by Miss Payne." He mentioned her. He didn't hide her, but his authority carried more weight than her priority. The astronomical community only accepted the idea once Russell backed it, not when Payne proved it. For decades, Russell's 1929 paper was cited as the one that established hydrogen as the primary component of the universe. Cecilia Payne's name was relegated to a footnote. Meanwhile, she continued to work at Harvard. For years, her title was merely technical assistant, underpaid, no official status. Harvard President Abbott Lawrence Lowell explicitly stated that a woman would never hold a professorship there as long as he was in charge. It wasn't until 1956 that Cecilia Payne became the first female professor in Harvard's Faculty of Arts and Sciences. Today, we know that 74% of our galaxy's mass is hydrogen, and 24% is helium. Everything else is just 2%. These numbers are exactly what Cecilia Payne calculated in 1925. Astronomer Otto Struve called her dissertation undoubtedly the most brilliant PhD thesis ever written in astronomy. The American Physical Society placed her discovery alongside those of Copernicus, Newton, and Einstein. Without her work, the theory of stellar nucleosynthesis wouldn't exist. Without her, we wouldn't know how stars are born, how they burn, or how they die. In 1976, she received the most prestigious award from the American Astronomical Society, the Henry Norris Russell Lectureship. The same name, the same man, Cecilia Payne, accepted the award, and she told a room full of astronomers, "The reward is not only the honor, but the fact that it bears the name of a man who once thought my most important work was wrong." Was Cecilia Payne a victim? She would say no. She got her degree. She kept working. She lived to see the recognition. But the truth is, one sentence from an authoritative man delayed the acceptance of a massive discovery for years. Not out of malice, but because of a hierarchy where a young woman's voice carried less weight. She discovered what the universe is made of. And the ultimate question isn't who did it. It's why did it take us so long to listen? Subscribe. A new story will be waiting for you every week.